Firstly, we want to start with some important bases talking about how to use derivatives and how to make some applications on differentiation. So, first we need to remember that the existence of limit, which is the first part in the lesson, needs us to remember when does the limit exist. The limit of a function exists at a specific point, which is x naught. That's in case limit from the left and limit from the right are equal. So limit exists in this case. We also studied the continuity of the continuity condition. Thus takes two parts. The first one adopting on the limit and saying that if the limit exists at a point x naught and the function at the point x naught, the value of it is equal to the value of the limit, then those two parts telling me that my function is continuous. After that, we talk about differentiability of a function. So when is the function differentiable? It is differentiable if we substitute x, a specific point like x naught, what we were talking about previously. When we substitute it in the function, it gives me exist value. So the derivative in that time exists. So this is the idea of the differentiability of a function. When we derive a function, in the truth, we are using a function in the form of y equal f of x. So when we talk about y, so y is dependent variable. Why does y is dependent? Because y is depending on the value of x that inputs in the function x, in the function f of x. So f of x is a formula using the input x to give a value which is called y, and this y is depending on x. That's why we say y depends on x and x is independent variable. Such an idea is important to be able to distinguish between the independent variable x and the dependent variable y. Some rules of differentiation are known from last year. We have to know them, but we want to just revise them very fast in order to remember them. If we have a constant function, so the derivative of constant is 0. And if we have x power n, that's a term with power, and the base is the variable which is called independent, then the derivative of the function is by putting the power beside the function and subtracting to get the new power. And if it is in case 3, so in the truth they are similar, if we look at them, then we will just multiply n by a, and it's going to be an and x power n minus 1. After that, we will talk about if we have more than one term or we have two functions added together and you want to derive them. So since they are added or subtracted, so each represents a separated term, that's why the derivative is clear and easy by deriving each term alone. And if we have a product, so they are one term, it's different than being separated. So now since they are one term, so the product rule is known as first by derivative of second plus second by derivative of first. And in case we are talking about dividing functions and we want to derive them, so we will use the word denominator 3 times. Squared denominator, that's in denominator, and we will use the word denominator, which is talking about g here, for example, in the beginning of the numerator and in the end of a numerator. We will say denominator by derivative of a numerator minus numerator by derivative of denominator. So we start with denominator and end with denominator.